Okay, here we have passage 4. Let me just take a quick glance at it. I can see that it's about electricity. It's got a little kind of diagram of a power supply and stuff. And then it's got two other graphs that have keys. Alright, so as always, I'm just going to start with the questions. I'm not going to read anything and just read what I have to answer the question. So, question 21, according to figure 2. So I will find my way to figure 2, and that is down here. The maximum positive value of Vs was approximately, so I know I need to find Vs. That's this, it's the dotted line. The maximum value is obviously when it's going to be at its highest, and it's asking me for volts. And you can see here, and the ACT does this quite a bit. This y-axis is talking about current, and this one is voltage and V. So when I'm reading it, I want to go off here for the volts, since that's what the answer choices are in. And it looks like it's about 250, and that would be C. 22. A period is the time required for a wave to complete one full cycle. Based on figure 3, the period for VL was. So we come across here and we find figure 3. It's right here. VL is this one, and that means it's the larger dotted line, so it's this one. And a period is just when a curve goes back to where it started. So it starts here, it goes down, it goes back up, back to where it started. So that's the period, that's all it means. It started at about 50, when it comes back to about 50, that's the period. We look along the bottom here, and that is 20 milliseconds, and that is H. So we're going to go on to question 23, and it says, according to figures 2 and 3, which voltage varied the least? Alright, so it's the least during the millisecond interval. And I think, hopefully just common sense is, it's going to be the wave that has the least amount of curve, right? Like you see here, with say this one in figure 2, this one has its maximum, it's 25 if we're looking at the amps thing, and at its minimum it's like minus 25. It's got a big steep variation. So we don't want ones that go like that. We want ones that go like that, because that's the least amount. And we see that in the graph that we just used. Is this one. It's very shallow. It starts at 50, goes down to about 50, and then comes back. So it's got a very little variation. And what is that? That is VC. No, it isn't. I've just drawn over what the dickens is. It's a large dotted line, so it's VL. Things not to do in the test. So it's C. Alright. 24. Polarity refers to whether a voltage is positive or negative. A voltage of 0 has no polarity and can be ignored based on figures 2 and 3. So again, we're going to have to look at both of them. Which two voltages were always opposite in polarity? Okay, so opposite in polarity would mean that when one is going up, the other is going down. So we're looking, if one's going up and down, that one would go down and up and kind of mirror each other. So we look at figure 2, and those two don't mirror each other. They kind of follow each other, but at no point do they kind of mirror each other. They're both kind of going up at the same time and then kind of coming down at the same time. So if we look at figure 3, we can see that we can kind of see that. We see this one goes up and then comes down, and then this one, it intersects here, and when this one is going up and down, this one is going down and up. So those are the two that we need, and that's going to be VC and VL, and that is, they've got it as VL and VC, but it's H. 25, based on figure 2, at which of the following times was the current in the circuit flowing counterclockwise? All right, flowing counterclockwise. I don't know what that means, so that means I'm going to have to read some of the passage. So that's when you just are going to, really read quickly. I'm going to do it a lot more slowly because this is obviously a video that's trying to explain things, not do it at real speed. But this is when you would skim it and you're just looking for the word counterclockwise. So you would just start at the beginning, and if you skim the first 3 sentences, there is no mention of counterclockwise. So we come down to this second paragraph here, and we'll start scanning it. Oh, and we see clockwise there, so that's probably a clue. So clockwise is positive, counterclockwise is negative. All right, so that's a bit of information that we needed. So it's asking, based on figure 2, which of the following times was the current in the circuit flowing counterclockwise? So when was it negative? Right? So at 0 seconds, well, it's 0, and we know from the question up here, the 24, at 0, it's got no polarity. So it's not negative, it's 0, and here it's negative. So it's not flowing counterclockwise. 5 seconds is here, well, positive. 10 seconds is here. Again, we get this 0 and positive. And then at 15 seconds, we're here and they're both negative. So that means it's answer D. Okay, let's go on to question 26. The table below lists the electric charge in microcoulombs, whatever that is, who cares, stored on the capacitor at 3 different times during the 20 millisecond interval. Fair enough. Based on figures 2 and 3, did the charge on the capacitor more likely change in sync with the, it's an italicized L, or with the VC? All right, so L is here, and it's between, we need it between 7 seconds and 13 seconds. So I'm going to mark that on both. So we're looking at 7 seconds here and 13 seconds. So we're looking at this block of time. And here I'll mark it in figure 3, 7, 13. We're looking at kind of this block of time. So L is a solid, in figure 2, L is the solid line. So we see here the solid line goes down, it just goes down, right? And here we're looking at, in figure 3, we're looking at VC, which is a small dotted line. So it goes up and then it goes down, right? It goes up and then it goes back down. So now we have to look at the table, and what's it doing? It starts at 51, goes up to 87, and comes down to 51. So it goes up and comes down, and that's what VC in figure 3 did. So we know that we're looking for, what was it in sync with? It was in sync with VC. So we can get rid of F, we can get rid of G, and now we just have to make sure that the reasons for it are the same. So H says VC, over that time interval, both the charge and VC decreased and then increased. No, they increased and then decreased. So that one's out. So J's right, and we can check it by just saying over that interval, both the charge and VC increased. Yes, they did. And then decreased, went down. And you see that here, it increased to 87, went down to 51. And that's Answer choice J, and that is passage 4 finished.